Something's wrong with gravity, and it's not what you think. A tiny magnet can lift a paperclip effortlessly, yet the gravity of an entire planet struggles to do the same. How can the force that holds galaxies together feel so fragile here? Is gravity truly weak, or has most of its strength slipped away into somewhere we can't see? Stay with me, because this mystery might reveal that our universe is just a thin film floating above deeper dimensions. For decades, we treated gravity as a mathematical oddity. Maybe that's just the way nature is. But some physicists refused to believe it was coincidence. They began to wonder, what if gravity isn't weak at all? What if most of it lives somewhere we can't see? Imagine our universe as a thin, luminous sheet, a three-dimensional membrane, floating in a hidden ocean. Everything we know, matter, light, space, time, is trapped here. But gravity is the wanderer. It leaks into extra dimensions, spreading its pull outward into realms we cannot perceive. And honestly, it's probably just stretching its legs after eons of work. And as it spreads, its grip on our world thins, like light fading as it spills into darkness. But wait, how do we even know this, when we've barely peeked beyond our own three dimensions? We know because gravity itself whispers the secret of the unseen. There's a deep connection between how gravity weakens with distance and the number of dimensions it spreads through. In our familiar three-dimensional world, that relationship is captured by Newton's law of gravity. Keep an eye on that tiny r, the distance between two masses. It's about to reveal something extraordinary. Now, imagine we add just one extra dimension. The familiar inverse square law, where force falls off with r squared, suddenly becomes an inverse cube law. The distance r now spreads gravity across more directions than we can see. At 1 meter, the difference is subtle, almost invisible. But move to 2 meters, then 3, 5. And with each step, gravity in 4 dimensions crumbles astonishingly fast, far more than in our three-dimensional slice of reality. Let's think of it like gravity multitasking. It has more ground to cover, so its pull on our tiny world weakens faster. Even a small change in distance now feels huge. What seems minor here can mean the difference between a barely moving paperclip and a force that shapes galaxies. And this is why the same force that binds galaxies together barely moves a paperclip here on Earth, and also allows us to glimpse the possibility of higher dimensions. And right after the mathematical revelation, physicists race toward detection, here in our three-dimensional world. In the late 1990s, Randall and Sundrum proposed a radical idea. Space itself might be folded, an invisible valley beside our universe, curled and warped in ways we cannot see. Near one side, gravity rages and roars. But by the time it reaches our brain, our slice of reality, it's just a whisper, a faint echo of a force raging elsewhere. Today, scientists build delicate torsion balances, golden spheres thinner than a hair, suspended under laser light, trembling just fractions of a millimeter, searching for the edge of another dimension. So far, silence. But in science, silence is never empty. It's the space between discoveries, waiting for the next breakthrough. Maybe gravity isn't the weakest force at all. Maybe it's the most generous, spreading itself across unseen vastness, holding worlds we'll never touch. And yet, it still can't hold my coffee. Perhaps we are just the faint reflection, anchored to a fragile sheet of space-time, while the full symphony of gravity plays in higher dimensions. And one day, when our instruments finally listen deep enough, we might hear it, the music of gravity returning home. And if this journey through the hidden dimensions stirred your curiosity, consider subscribing so we can explore the mysteries of the universe together.